Okay, on problem 891, we're given an equation. We're asked to solve for real numbers. All right, what real numbers make this a true statement? So as always, we go through paper and pencil work if we can, and we get an answer to it. All right. So what I want to do is just talk about using Sage to verify it. And I also, let me see if I can do Newton's method. No, but Newton's method I didn't do over here. You know what? I did do Newton's method over here. I'm sorry, I'll go through that as well. So let me go to Sage. I'm going to clear the screen out for you. I'm going to reset, and that's a good policy to start with that. Define a variable x, and then I'm going to solve an equation. All right, now someone says, what equation are you going to solve? Let's go back over here. I'm trying to solve this equation over here. So I'm going to ask Sage to see if it can do it. So x to the what? X to the x, that's not so bad, equals. Now equal in Sage is an equation, it's a double equal sign. And 4, if you use a single equal sign, it's an assignment operator. So I'm going to say x plus 4, that goes in parentheses. And we're solving for the letter x. All right. It returned, and what does it do? It just repeats, it doesn't do anything. All right, so over here, that really didn't do a good job. Now, what I want to claim over here is a lot of people don't know where the root might be, and that's a problem. So what I want to do is I want to graph things. I'm going to go to Grapher. Let me just get a rough graph over here. And again, you're free to use whatever software you want, including Sage. Sage can graph as well. And I'm going to say x to the x. I want to graph that out. Looks like that. And what else do I want to graph out? 4 to the x plus 4. Let me put that down for you. So y equals 4 to the x plus 4. And I'm seeing something there, and I was wondering what's going on there. Do they ever meet each other? So let me kind of zoom out. And you might say, they'll never meet each other. Let me keep zooming out. And I realize I can't see the detail anymore. So what I'm going to do is I'm going to really kind of focus in on this region over here. And let me keep zooming out. I think you're getting an idea that I'm doing a lot of zooming. And let's zoom out again. I'm going to zoom in again. And let's take a look. And I'm sorry, not zoom in, but zoom out again. Let me get in there. I will say they're getting closer and closer together. And I really zoomed out there, didn't I? Let's see what happens over here. All right, I'm going to zoom in again. I'm using a little cursor over to do that. This is why I like Grapher, but that's kind of up to you. And I'm kind of seeing a solution over here. All right. Now, someone said, where do you see that solution? I'm going to say, looking at it, it looks like it's between 5 and 10. All right. Now, granted, looking at it, I'm going to say it looks like it's close to 8, just looking at the picture. Again, I can zoom into this over here. Let me just put out what I mean by that. And I'm saying it's convincingly look like it's really close to the number 8. All right. So what I want to do is go back to Sage. And I'm going to find the root. I'm sorry about that. I didn't go back to Sage. Let me do this too. So find root. Again, Sage couldn't solve the equation, which is kind of surprising. But find root, f of x. And then what I got to do is I got to give it a region that I believe that solution occurred between. Now you notice over here, I'm thinking it's around 8. But right now, I got to give it bounds. So, 7.5, that's really playing it safe, up to 8.5. And Sage is going to use a numerical method to come up with a solution over there. And you know what? I think I made a mistake somewhere, and I'm wondering where I made a mistake over here. Oh, you know what? I don't have an f defined, and that's why. Let me go back over that. And I got to type the equation in. What equation? This equation right over here. Same equation, but I'm using a different command. I'm not saying solve it. I'm saying find the root. Can you find the root of that? And what does it give me? It gives me this number over here. Now again, I'm wondering, why doesn't it come up with the what I believe the exact answer, which is 8? But I'm kind of looking at that, and I'm going to say 8 looks like a pretty good, guess at that. So what I'm going to do is use a Boolean, and I'm going to evaluate, let's see, x to the x, which would be 8 to the 8. I'm actually believing that with the picture and with this find root business. And I'm wondering, is it the same thing as 4 to the power, and what's that power going to be? 8 plus 4. Again, I want to go over what we're doing over here. I believe 8 is the solution over here. So 8 to the 8, no, I'm not going to compute that number. But is that the same thing as 4 to the 8 plus 4, which would be 12? And what is it? It says it's false. Oh, you know what? I see why it's false, because I have an underscore over there. Let me go back over that. I mistyped. It's a true statement. All right? So I also want to claim that you could define a function, and I'll go through this with you. And I want to tell you what f of x is. Again, going back over the notes, it's this equation here solved for 0. So it's x to the x minus 4 to the x plus 4. This is typical when you're using something like Newton's method. But Newton's method is particularly problematic here because the slopes of those curves are just really enormous around the solution. So what I want to do is just play around with it a little bit and define Newton's method. It's typical code. It's you're taking some initial guess value x minus the function evaluate that guess value divided by the derivative with respect to x evaluated at that x value. And then you give it a seed value. And I'm going to say the seed value I'm going to give it is, I don't know, let me just ballpark it and say, I don't know, maybe it's about 7.9. All right. I guess I could, you know what, let's use this seed value over here. Let's see what happens. Okay, so what are you going to do now? You're going to, again, this is Newton's method. I want another guess. So what do? I take this one and I say, I feed it to Newton's method. Newton's method is going to compute a number for it, and then it's going to return it to x, but I want an approximation of that. And what does it give me? Wow, exactly 8. All right, so if I try it again, it's going to give me exactly 8. Now I want to do a different seed value. Let's say I said it was about, I don't know, let's say I said it was 6. I'm going to put 6.0 in. And I did the Newton's method again. I want to see what happens. I get that number, right? At least I go further away, right? I get that number. I got that number. It's not narrowing down to anything in particular. I got that number. You notice it's getting slower? You may wonder why that is. Sage is trying to do some exact arithmetic over here, and this gets really complicated. And I will display that arithmetic later. But it's problematic, and the reason it's problematic is the seed value I gave it was so far away from the solution, and these slopes are huge, and this thing, these tangent lines are going all over the place now. You notice it's slowing down, right? I'm going to kill it, indicating it's not going there anyway. It's not going to go to how long I wait. Let me just kill that off, and whoops, I didn't do that. Oh, I think I killed the whole thing. Let me just, oh no, there it is. I'm sorry. Let me go back to Sage. By the way, Sage, I still have the x value. It hasn't reset. So I want to display the x value for you. You know what? Maybe I did kill it. I mean, I just wiped everything out. You know what? I'm going to try again. Let's try again. Let's do reset. Let's do x is a variable. Let me, again, I'm going to copy paste because, it's already there. So I'm going to do this f of x. I'm going to do Newton's method. And then I'm going to take a seed value, and I'm going to do the seed value of 6.0. All right. And again, the reason I want to show you what Sage does for the number. So x equals Newton's method. And I'm not going to, I'm going to display the x, but not the approximate for it. So just the x. And you notice it gives me this over here. Now, if I keep repeating this, you're going to notice the number's getting worse and worse over time. I think you can appreciate how bad that's getting. But it's doing those computations. Now notice it's really, if you want to know how long that is, I'll just scroll back over it. All right, you get the idea how long that is. If I want a numerical approximation of that, though, it's going to be computing every single term and adding them together. That's why it's bogging down, all right? So it's unproductive. So it does come up with the number. But the number's in the wrong direction. Again, the slopes are huge. So again, I would use fine root. So someone says, well, what algorithm are they using? You could actually go to the Sage website and read about fine root. you can find out exactly what they're doing to do that. And that's what's really important about open source software. You can find out exactly what they're doing to compute that. You couldn't do that with Mathematica or MATLAB. You just would have no idea what algorithm they're doing to use that. All right, proprietary. Thank you.